Next, we will introduce the natural logarithmic function and discuss its properties and significance. Let f of x be a logarithmic function with the base equal to the Euler's constant e. Such function is called the natural logarithmic function, and it has very nice properties that make it worth studying. But first, let's graph it. Since e is less than 3 but greater than 2, the graph of ln x sits right between the log of x base 2 and the log of x base 3. However, we can also construct the graph by evaluating the function at some values and then plotting the points and connecting them with a line. Of course, the natural logarithmic function has the same properties as any other logarithmic function with the base greater than 1. That is, the x-intercept is always 1, on the left the graph approaches the y-axis, and on the right the graph goes up indefinitely. If we let f of x be the natural logarithmic function and g of x any other arbitrary logarithmic function, then the following manipulation can always be performed, meaning that any logarithmic function can be expressed as a linear transformation of the natural logarithmic function. So in some sense, the natural logarithmic function is the parent of all logarithmic functions. It is hard to ignore the relation between the graphs of the natural exponential and the natural logarithmic functions. Using the properties of exponents and logarithms, we can show that one is an inverse of the other one. Therefore, their graphs are each other's reflections through the line y equals x. We introduced the natural logarithmic function and discussed its properties and significance.